All right, so we've come back after some time off. We've selected a lovely one-star fog puzzle to kick us off. Let me just check. Yes, it is a one-star puzzle. It's called A Drive Through the Fog, and it's by Carmen Lambert. Warning, the magenta Renbar line is now yellow. Okay. Looks like there's a lot of rules, so let's go through it slowly. Normal Sudoku rules apply. Digits along the yellow Renbar form a set of consecutive non-repeating digits in any order. So Renbars are normally pink or purple or magenta apparently, but they're yellow. So this is going to be our Renbar line, and it has to be a set of consecutive digits in any order. So this is a Renbar line of length 2, so it just means that they're consecutive. But if it was a longer line, it could be a slightly larger set. Adjacent digits along a green German Whispers line must have a difference of at least 5. Digits along a blue line create a sum line, where the sum of digits on a line within a particular 3x3 box must be the same for all boxes that the line passes through. The sum of digits... Okay, but hang on, just give me a second, because usually the line is broken up into segments with the sum of digits on a line. I think that's what it's saying. Sum of digits okay. So what I'm assuming is that the blue line is going through multiple boxes and it gets broken up into segments by those boxes. And those segments of line have the same sum. Okay. Digits along diagonals pointed to by arrows outside the grid must sum to the numbers listed. Okay, boom. These sum up to 17, right? Cells with a filled circle must be odd. Cells with a filled square must be even. A black dot between cells indicates cell values with a 2:1 ratio. White dot, the values are consecutive. Not all dots are shown. V, the values sum up to 5, and X, the values sum up to 10. Assuming not all X's and V's are shown. The board is covered in fog. Place a digit correctly and the fog will lift around the digit. All right. There's a lot of rules, but all fairly standard. So this is going to be our odd digit. And I like to color in odd digits orange because it's an easy way to remember. Here we have digits summing up to 5. So it's either 4 and 1 or 2 and 3, right? We know immediately, which means that this is 9, 8, 7, or 6. And then this has to be consecutive. With whatever that is. It can't be 5, because you can't have a 5 on that side, for obvious reasons. So if it was a 6, it would be a 7. If it was a 7, it could be a 6. Or an 8. 8, 7, 9, 9, 8. Okay, so it's actually the same digits, which is kind of not what I was expecting. Okay, now we can rule out some. Can't be 7, can't be 9. 6 is either 3 or 4, which is going to be half that. Double is out of the question. So this is resolving itself to some degree. So that's not the 4. That's not the 9. 6, 7, 8, 3, or 4. So we have a 1, 2, 3, 4, which is quite nice. There is an X there I can just see. 7 is 6. This is an odd number. And it's not from 1, 2, 3, 4. It's a 5, a 7, or a 9. 17 is a fairly large number, but it's not too large. So not going to worry about that right now. That can't be the 3 over there, because then I would put a 2 here, and then I'm not able to be... what am I saying? No, sorry, ignore that. 3, 4, 2, 3, 4, 4, 3, 3, 4. Hang on a second. Do we know for sure that one of these is a 3? Is that what I just discovered? 2, 3, 3, 4, 3. We do. So that's not a 3, which means that's actually not the 2. It's not 4 and 3, or 3 and 4, which means that's not the 8. Which means, hang on a second. How could this ever be a 6? Goodness, I hope I haven't made a mistake. But we're going to commit to it, because I never make mistakes. Sorry, that's a lie. Just retracing my steps. 3, 7, 4, 6. It's not the 8, but it actually can't be a 6. So, because it's not consecutive. So that's the 8. That's the 7. That's the 3. That's the 4. That's the 6. That's a 2. That is not the 7. It's a 5 or a 9. Can't be a 6 over here. So if it was a 5, it would have to be a 4. And if it was a 9, it would have to be an 8. But 8, obviously not going to be able to sum up to 5. So it's going to be the 4. That is going to be the 5. This is going to be a 1. This has to be consecutive. 6, could be 5 or 7 actually. 4, well, if you have a 4 on a Renbon line, a German Whispers line, you add 5 to that, you do get a 9. And then you're going to get a 3 over here, 2 or 4. I mean, this is fairly straightforward. 1, 3, 5, 7, 4, could be 5 or 3. Oh, 7. Well, 7 has to be in one of these spots. 7, 8. Okay, so it's going to have to be 7 and 8, just because of normal Sudoku constraints, which makes that's the 5, which means this is a 4 or a 6. Okay. What is this? 1, 2, 3, 4, 5, and 9. Okay, so that does resolve to a 7. We've got a double here. Could be 2 and 4, 4 and 8, or 3 and 6 actually. Okay, 2, 8, 6, 3, 4. Okay. That's a bit weird. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're missing a 9. It's gonna have to go there. 3, 4, and 6 up there. Because we still need a 6. So that's not gonna be 6, which means that's not gonna be the 3, which means it is gonna be the 4. Which means that is gonna be the 8. And that's a 6, so that's a 3. 159, that's a little bit confused what just happened right there. Okay, we're a bit rusty, guys. We're a bit rusty. We put in 8 over here, when it of course can be a 2 or an 8. So let's have some grace. 4, 2, 2 and 8. Well, we know this is a 2 and 8 combo. And if that's a 2, that can be a 1 or a 4. And over here it leaves us with 1 and 1 and 6. Sorry, there's a very weird sound coming from downstairs. If that's a 6, then that is a 1. But if it's a 1, it could be 6 and 8 or 9. Oh, this has to add up to 17. And we have quite a small number. And if that were a 2, we would not be able to reach 17 as we would need 11. So that's going to be the 8. That's the 4, that's the 2. And this has to be a 5. And those ones, I don't think we know what they are just yet. 7, 8, or 9. Picked up a 2 here. We've got a bunch of even numbers. Let's color code that because that's always fun. If that were a 7, it would make that a 1. Which would make that a 2. Which is very reasonable for an even cell. If it were an 8, it'd be 1 of 3. If it was 3, could be 4 or 2. Well, those aren't 2. Let's just put some options in for us here. Well, this has to be a low digit. So 8's never going to work. Because low, high, low, right? 1, 2, 3, or 4. Well, actually, it's 1 or 3. Both of those are valid for 2, so we're not going to get a digit just yet. But that is going to be the 2. I think this is a fairly long German whispers line, because I can just see it peeking through that corner of this cell, top left corner. 6 and 1, has that created any problems for us? No. Should we be playing some Sudoku, maybe? I don't think so, because we will have all our numbers in the bottom here. That would be a bit silly, I think. 4, 6, and 8. Excuse me. Oh. A little bit puzzled. See if we get anything with 5. So the line is going through here. I can clearly see. So 5's in one of those two positions, as far as I can tell. Don't think this is going to get us very far. Seven, 8, 9. One or 3. Seven, 8, 9. One, 3. That's also 1 or 3. Six. Never mind. 7, 8, 9. Once again. And I'm getting a bit desperate for a digit over here. Ah, of course. This is what we were meant to notice. Low, high, low, high, low, high, low, high, low, high, low. Yeah, well, we've definitely slowed down a bit, haven't we? Definitely slowed down a bit here, which I don't like. But I'm just not sure about a few things. 1, 2, 3. This actually has to be a 7, 8, or a 9. It can't be anything else. And if that's true, then that is true. Which means that is a 5. Boom. We did it. Now, do we immediately get stuck again, or do we actually achieve something this time? We got a digit. I'm not going to explain how I knew that, but I knew it. I just looked at these 5s. Anyway. This has to be 7 and 8. Six, 7, 8, 9. Yeah, there's just so many pencil marks and not enough actual things. Oh, wait, that's the only place I can put a 6. Well, okay then. I mean, wow, took me long enough. My goodness. Seriously. All right, numbers coming easily enough. Surely there's only 1, 3, 5, nope, 7 and 9 still possible. What is this? Some kind of little houses, digits along a blue line. Yeah, so I'm assuming that what it is telling us is that the sum of that must be the same as the sum of that. Must be the same as the sum of whatever's happening in here. I mean, I'm assuming that's what it has to mean. Four, 5, 6, 7, 8. So if we figure out the sum, we'll know what that is. You know, my break timer. I mean, now I have to play some Sudoku over here. You know, I mean, if that's a 9, I mean, that's... No, that makes sense, because this line is a lot longer. So it could work. Threes over there, you know. Fours, fives, we already looked at. Okay, we do have a 6 over there. Took me a while to notice. We do have an 8 there, which means we have a 2 there. Which means we have a 2 there. And we've just got to play Sudoku, you know, is what it is. Where are we at with 5s? I mean, 835, right? 835. These are the same digit. But it's not forced. It's a 7 or a 9. That's another 7 or a 9. I mean, you know, it does mean that that's a 9. And it means that these are 3 and 5. Okay, so what do we have here? We have 11, 13, 22. And then plus that, so it's either 25 or 27. And over here, we have 16, 25 or 23. So that has to be the 3 then. And that's the 5. And then this is the 2 9s, the 2 7, the 5 and the 3. Good show. Got through it finally. Just that one real major sticker, and then we rolled much more freely.